What I'm going to do in this video is show you how to do the cross tabulation of two categorical variables in JUMP. So the cross tabulation is helpful when we're interested in asking questions about the association between the two variables. And in the data set that I'm looking at here, there are two variables that I'm interested in. One is the intent to purchase of a particular individual. So each row in the spreadsheet corresponds to an individual. The first column says, did they intend to purchase a certain product, let's say it's a car, within a certain time frame. And the second column looks at that individual later on and says, well, did they actually go out and purchase that product? Let's say it's a car again. So intent to purchase versus actual purchase. And a question of interest would be to see whether or not they were related or associated with one another, because it's almost certainly the case that not everyone who plans on buying a car in a year ends up doing so. So what does the association look like? In order to get a sense of that, we're going to cross-tabulate the two variables, and it's important to note here in the JUMP framework that we've got the red bar chart there for both variables, indicating that they are being treated as nominal. And then to do the contingency table, the cross tabulation, I go to Analyze, and then it's the Fit Y by X menu that you want. You want to choose one of the variables as being the X, and here it's natural to put purchase intent in as the X, and we're going to say, does knowing purchase intent tell us anything about actual purchase behavior? So that one goes in as the Y, and that's all that I need to do. I click on OK. Now here's the typical output from the contingency table analysis. And first of all, I'm going to talk about the table, and then I'll come back to the plot in just a second. So here you can see what is called the contingency table, or the crosstabs, and it has counted the number of rows in the spreadsheet that fit in each of the levels of the cross classification. So in the rows here, we've got the X, which is the purchase intent, which is either no or yes, and going across the columns, we've got the actual purchase behavior over the coming year, which was no, they didn't purchase, or yes, they did. And the way that JUMP displays the information is in fact described by looking at the cell that's out of the table up there that has four statements in: count, total percent, column percentage, and row percentage. And that tells you what each of these numbers in the table correspond to. So the top number corresponds to simply the cell counts. How many observations out of the total of 983 were in each cell? The second number is the percentage of the total. So for example, the 39.67 is obtained by doing 390 over 983. So that's a cell-wise percentage. The column percentages are obtained by focusing within a column, and rather than dividing through by 983, dividing through by the total within that column. So let's say the 74.43 there, that is obtained by taking 390 and dividing by 524. So 74% of the observations in this column, where actual purchase was no, lie in the no intent to purchase category. The final number in the table are the row percentages. We get those where rather than dividing through by the overall total, we divide through by the row total, 657 and 326. And here, let's look at the 58.9. That says that 58.9% of those that say they plan on purchasing actually end up purchasing. That's what the sort of main number of interest here, really. Whereas of those people who don't intend to purchase, only 40% of them end up purchasing. And the fact that this 58.9 is so much different from the 40.64 tells you that there is an association between intent to purchase and actual purchase behavior. So that's what's going on inside the table. Have a quick look at the Mosaic plot. And the Mosaic plot is just a way of presenting the row-wise percentages to you. Remember, these are the numbers at the bottom of each cell, and you know that the row-wise percentages because it tells you. in terms of the legend up here. So let's see if we can understand what's going on in the Mosaic plot. So first of all, you notice that there's much wider bar for the no's than there is the yeses. That's reflecting the fact that there's simply more no's in the data set for purchase intent than there are yeses. 657 against 326, 67% against roughly 33%. So this bar is twice as wide for the no's as it is the yeses. That's allowing the plot to follow the area principle. Now, if we look within any one of the bars, so let's say for those that had purchase intent no, then we can see the reds here corresponds to the no for actual purchase behavior, and the blues correspond to a yes for actual purchase behavior. And we can, for example, by taking the crosshairs, see what is the height of that particular box, and it's 0.59. So 59% of those that didn't intend to purchase ultimately didn't purchase, and that's the 59% in the table there that I'm pointing at. Likewise, for those that said they were going to purchase, so their intent to purchase was a yes, if I click there I can see 41% of them are in the red area, meaning that they were no's, therefore 59% of them were yeses, and there's the 58 or 59% down there. So the summary is that the Mosaic plot is just presenting in a graphical way these row-wise percentages that are displayed in the table here. There are other things that you can add to these plots if you want to, and if we go, for example, to the contingency table, if you click on the little red triangle there, one of the things that one might be interested in adding in is the chi-squared for each cell. If you remember, that's the observed minus the expected squared over the expected within each cell, where expectation is being calculated under an independence or no association assumption. And down here at the bottom under tests is a number that we will talk about in due course, and that's called the Pearson chi-square statistic, which here is 29.176, and that's just the sum of the chi-squareds in each of the cells of the table. So you can add more things into the contingency table if you want to, and of course you can take them away if you think that it's too busy. So we could remove features in here as well and ultimately just present the counts if we wanted to do that. So you have some control over how the output is displayed. So that is our basic output for looking at the association between two categorical variables.